Hello, I'm Brian Gleason. I'm a Mastercam expert out of the Phoenix, Arizona office. Today I'm going to be talking about the changes in 2023 with Multiaxis, specifically the unified toolpath. So I have 2023 open right here, and if I go ahead and look into the Multiaxis gallery, expand that, it's going to be a lot more simplified and a lot less options to be looking at. Now, I'm going to run with 2023 in a dark theme and 2022 with the light theme just to make sure we can see which is which. If I expand the multi-axis gallery in 2022, I can see that I have quite a few more options. Well, what options are missing? Again, I'll expand the 2023 gallery, and what we're going to notice is that morph, parallel, along curve, and project curves are no longer in the gallery. That's because they've all been combined with the unified toolpath. So instead of having to pick each cut pattern specifically, we'll now run it through the unified, pick our cut pattern inside of there, and nice thing is we can always change it on the fly we'd like. Now, what about our old toolpaths? Older programs that open them up into 2023. So I'm going to go ahead and open up a sample part. And inside of here, we can see we have parallel, morph, long curve, and project curves. So the ones that are seemingly missing from 2023. I'm going to open up that same part file in 2023. And what we're going to notice is it automatically comes in and converts them to a unified toolpath for us. So as we can see that we now have unified parallel, unified morph, unified perpendicular, which is a long curve, and the unified project. Let's go ahead and I'm going to shrink this guy down a little bit. So scrolling along the 2022 on top, we have parallel, morph, long curve, project curves. 2023 on the bottom, unified parallel, unified morph, unified perpendicular, unified project. So let's just look at some of those options inside of there. If I go into the project curve parameters, cut pattern, we're going to do projection, and we're going to be in z-axis machining geometries. So all the parameters that would be used in a project are still inside that unified. So we get cut pattern, project, same Mastercam logo. The machining geometries are going to be the cream colored faces. And then our options are we're projecting it down in the z-axis. So again, it's not that they're totally completely missing, they're just not in the gallery, and we're using the same logic. It's just the unified is kind of working as like a user interface to be able to select everything and give us the ability to adjust everything on the fly and be able to change our cut patterns without having to have several different toolpaths just to see the cut pattern we want. There's another awesome feature I want to talk about with the unified. So I'm going to go ahead and open up a sample part. And I'm going to open good old Abe Lincoln here. Now, there's two ways about going this. We can do a regular unified toolpath using a guide curve. And if I go ahead and get into the toolpath, a lot of back and forth, a lot of directional changes, especially we come into the ear area, doing a lot of tilt. So this is set up just to be ortho to surface. Well, to combat that before, we would go with a clean core technique. So let's look at the parameters of this before we get into that clean core. Parameters are just guide curve, one machining geometry, which is Abe's head, tool axis control, surface with tilt, ortho to each cut direction, collision control, off. Now our previous kind of workaround for that would be to simplify the toolpath by doing a clean core technique. So inside of here, we use the simplified shape as a drive pattern, and then use the collision checking to compensate the toolpath out to Abe's head. That worked for a long time, but we have something even better. Now, this one we have a nice consistent step over the machining geometries, but we have crazy tilts. This one, we have a smoother toolpath that is not tilting near as much, but the step over is going to be inconsistent to the actual geometry that we want to be finished. And the other issue was when you have that clean core, the further you got away from the drive surface to what you actually wanted for machining geometry, you're going to get some distortion. So let's look at what our new option is. I'm going to take this first unified toolpath. I'm going to just copy it after, and we're going to make one little change. So inside the cut pattern, parameters, tool axis control, we have a super awesome new option here. Tilt relative to reference surface. I'm going to come in, select my reference surface. So I'm going to turn off Abe's head, go to our clean core kind of faces. And I'll let that generate. And what we're going to see is that we now have a constant step over, but our tilting is going to be much better. So it's much more, it's just smoother. I mean, we're not having to tilt all the way around the ear and everything else. Oh, we'll get into his ear. So we're no longer having all those extreme tilts. So definitely a super cool option inside of here. Another option inside that tilt relative is the smoothing option. And that's just going to reduce the amount of axis reversals. And that will smooth it out and make the toolpath run a lot cleaner. We'll go ahead and just let this rip. So, bunch of irregular shapes, nice smooth toolpath to a relative surface that we're now tilting to. So, definitely one of my favorite options on the new features of the unified toolpath. So that's kind of like our traditional one where our clean core was inside of the head. I'm going to show another option. So I'm going to go ahead and open up. A little more applicable part. We have our unified morph, morphing between two curves. And what we do have is a bunch of tilt lines. This is how this toolpath was being controlled on for the axis control. I'll let this run real quick. Not real quick, I'll slow it down a little bit. If we get in here, looks smooth, and then all of a sudden, drastic tilt. So you can see those kind of little tilting hiccups inside of there. Also, creating all these tool axis control, I would have to go in, maybe do a wireframe, and we'll say normal to point, pick this space, create a line, and then I'd have to go and modify how I wanted that tilt line to be. A lot of work. Let's get something else here. On our levels, I have a bunch of lines just basically taken from top of the curve to the bottom of the curve and strategically placed exact points. Not really. They're just kind of randomized around. I'm going to use those to create a generic loft. We'll work all the way around. Just working our way. Awesome. I'll make sure that the normal direction is going out. I'll say okay. Now, what are we going to do with that? It's outside of the part. It's not following the part exactly. So definitely pretty random. Coming into our tool axis control, I'm going to change the control style to tilt relative. To reference surface, we'll pick the lofted surface that we just created. Turn on our smoothing. Let that generate. While she's thinking, I'll go ahead and turn off that new surface that we created. And what we're going to get is a nice smooth toolpath. And since it's not tilting relative to a surface or of the drive surfaces, it's going to just have a nice smooth action all the way around. So come in, even though that surface wasn't on our part, it was actually outside of the part. I mean, actually it was outside in certain areas and inside of certain areas. The tool is still going to tilt relative to our reference surface. I'm super excited about this option this year. I really can find a lot of good uses for that and make life a lot easier without having to do the clean core technique. Plus, we're going to have a better step over, less distortion.